Brought to you by Molds Plus International, the producer of UltraPurge. I'm Josh Durrell, Director of Business Development for IDES. I'll be moderating the webinar. During the presentation, please send your questions by typing in the question box located on your screen. They will be addressed at the end of the presentation. We'll also be recording the session and making the slides available for download. Instructions will be emailed to you following the webinar. Today's presenter is Graziano Pestorino, the president of Molds Plus International USA. He has 15 years experience with the production of purging compounds and has helped many companies worldwide become more efficient during their changeovers. I'll now turn over the presentation to Graziano.
Thank you very much, Josh, for presenting, and thank you everybody for attending this webinar on how to do effective color changes. And we will start the presentation by discussing a little bit more in the process on, first of all, in order to become more efficient in doing color changes, material changes, we need to know our process very well. We need to understand our colorant, the pigment, know the polymer flow, the polymer that we are running, the type of colorant that we are running, as well as know the pigment design and the melt viscosity of the resin. Also, planning is extremely important. Whenever it's possible, it's always recommended to do a good planning of production, and also the process setup is extremely important. And definitely also using UltraPurge or purging compound during color change is extremely important. Basically, all of this is a system approach. Not only one of these points is responsible for making fast color changes, but actually, again, it's a system approach. So all of them together may help you to make a very fast color change and so increase your productivity. Now, start discussing about pigments. There are different kinds of pigments used in the plastic industry. There are what we call insoluble pigments and what we call the soluble pigments. Insoluble pigments are definitely in a solid form, while soluble pigments are in a liquid form. The plastic industry, the insoluble pigments are more popular than soluble or liquid pigments. And normally we can divide them into organic and minerals. Organic are normally non-effect pigments, meaning that they don't give like pearl or metal effect. And mineral pigments could be non-effect or effect, meaning that they give a sort of a pearl or metal effect. While liquid pigments are normally non-effect pigments and are widely used, especially in the PET industry, or we see a lot of companies using liquid pigments also for high throughput machines, especially also with polyolefin resins. Now, if we actually try to understand a little bit better how the pigments are, we will see that the organic pigments are actually much smaller compared to inorganic pigments. Such, for example, one of the most common organic pigments is the titanium dioxide. It's the white color, very widely used obviously in the plastic industry. While normally metal or pearl effect pigments are normally much bigger. As you can see in this little chart, they're actually even bigger than fillers, such as calcium carbonate or even talc. Now, this is very important to understand because based on the size of the pigment, also the effect of the pigment change. For example, organic and inorganic pigment, what they do is tend to absorb the light and reflect only the length wave of the color that we normally see. While, for example, metal or pearl pigments, they tend to reflect 100% the light that hits the actual color. And it's going to basically happen something like this, where the light hits the plate, and then it will be entirely reflected. Now, why is it important to understand the size of the pigment in order to make effective color changes? Because as you see in this little slide, because organic pigments are much smaller than mineral pigment, basically we need more pigment. We have normally more pigment per volume compared to a mineral pigment if we are always at the same dosing ratio, meaning that we have more pigment particles within our plastic that actually normally, because are much smaller, they have more affinity to metal or to get, let's say, stuck in what we are like microscopic crevices that we have normally in our machine, or they could be either in the screw and the hot runners. Now also, it's much more difficult to disperse an organic pigment than a mineral pigment. There is to understand, obviously, because there are many more particles of organic pigment per unit of volume, it's going to be much more difficult to make sure that the pigments are uniformly dispersed in the plastic compared to a mineral pigment. An example, actually a very practical example, is like if you're trying to mix the flour whenever you make it like a cake. If you don't mix it very well, the flour will actually become very, will stay together without being dispersed within the dough, I would say. While, for example, in the other case, the mineral pigment, because they're much bigger, it's much easier to evenly disperse them within the overall dough in this case. Also, because the pigment are much smaller, they tend, organic pigment, to actually group up together. And so many times we see, in talking about our specific application, the pigments sometimes they almost look like gel. Especially we see that in sometimes in some hot runner application, or even, for example, in the nozzle, the machine, we notice that the material group up in these spots, and it becomes really like a gel. So normally it's very, very difficult to be removed. Now, we briefly discussed about pigment, but also polymer. Knowing the polymer that we are running the machine is extremely important. As we know, plastic, when melted, moves inside the machine in what we call a laminar flow. Laminar flow is basically something very similar to what's shown in this picture, where basically we have many different layers that will move inside the, like for example, suppose that this one is a melt channel. And definitely the speed of the plastic inside this melt channel will change. Obviously, the plastic that is very close to the wall of the melt channel will have a very low speed, while the plastic that is in the middle of the melt channel will have a much higher speed. This is the main reason why it's so difficult to change color with plastics. Because if plastics, instead, being plastic and moving in a laminar flow, will move inside our machine, like for example water, it would be much more easier to change color. Now, also the shearing plays a very important role. As we see in the next graph in here, the shearing obviously very close to the wall of machine is basically almost zero, but then it increased drastically because obviously we have the difference in speed in between the plastic that is close to the wall of machine and the one right going to the center, while then it decreased and going back to zero almost in the middle of the melt channel. For this reason, many times when we, for example, see a hot runner system, we see that a lot of plastic will actually be, let's say, stuck, or will not move close to the wall machine, or even in the cavity that we are trying to fill out. Because again, the speed of the plastic in this location is basically very close to zero. So it is very difficult to actually remove that color or remove the resin. So that's why it's difficult to make not only color changes, but also material changes, especially when we're going from materials that they have a melt index, much lower than the resin that we're going to go to, that the melt index is much higher. For example, this is a perfect picture that shows basically some plastic that was pulled from a melt channel. As you can see, the inside, the core of the melt channel is actually perfectly clean. It's perfectly white. There is no black color in there. But the actual melt channel is covered by a black layer. Why? Because, as we were saying, the speed of the resin very close to the wall machine is basically zero, so it's actually not moving. So it's very extremely difficult to be removed. Now, there are many locations in the machine where we need to become more efficient, I would say, in order to make fast color changes. Again, we analyze the colorant. We start to understand a little bit better the resin, but also we need to take in consideration the whole machine as a system and making sure that every single location of the machine will be basically clean, or we will make in the condition to make fast color changes. So definitely, starting from the beginning, the hopper, or where we convey the resin to the machine, needs to be perfectly clean. We have many times with many customers that we actually clean the barrel or even the hot runners perfectly, but then as the first resin that's been loaded inside the machine contains, a little bit of color. Now, as we discussed before, it is sufficient, a very small amount of pigment, to actually dye many pounds of resin. So that's why it is very important to always keep the hopper of the machine or the gravimetric blender or volumetric blender prior the hopper or prior the filter of the machine clean. So definitely also the dosing unit is very important. Make sure that we have a good, efficient dosing unit, meaning that easy to fast and clean. There are many different kinds of dosing units in the market right now, and there are some of them that are actually great. You can pull the auger out very fast, or if it's a gravimetric blender, they have an easy way to remove the pan, and they're very, very easy to clean. So definitely, this is highly recommended to have a system or a dosing unit that is very easy to be cleaned. In the case of customers that actually use liquid colorant, we normally strongly recommend to make sure that in the feed throat of the machine we have a mixer, because sometimes dosing liquid colorant right on the feed throat, it could create some problem where the liquid colorant actually will go behind the feed throat. And if that happens, obviously it's going to become very, very difficult to clean the machine. So definitely, if we are able to inject or to dose actually the color right before the mixer, the liquid color will evenly coat the pellets of the plastic, so they can enter the machine and not to create other problems once they enter the feed throat. Definitely, as we all know, screw and barrel are extremely important. We know that it's much easier to clean a brand new machine than a machine that is 20 years old. Why? Because the condition of the screw is much better, as well as the condition of the barrel. Not only that, the screw design plays in a very important role, not only for purging purposes, but also for production purposes. Definitely, the nozzle of the machine is extremely important as well. Always make sure that we use good nozzle. Make sure that in between the nozzle and the barrel, we don't have mismatch. Again, as we showed before, it is sufficient, a little gap, to have plastic that will hang in there, will not move, so we stay actually there for a long time. Regarding the hot runners, there is actually a lot to be said, and for sure we will not be able to say anything in this presentation. And as for the colorant of the polymer, I'm just sharing with you the most important information that I can share in the limited time that we have. But definitely what I can say is that have a good hot runner system is the step number one of having fast color changes. we can have the best purging compound in the world, or the best solution, the best resin, the best colorant, but if the hot runner system that we are using is not designed for color changes, our color changes will always be very extremely long. So definitely, it is important to consult and discuss with your hot runners manufacturer, making sure that the hot runner that you are going to run meets the specs of the job that you're going to run. Meaning that if you know that you will have a lot of color changes within that particular job, make sure that the hot runners producer knows that, so they will be able to actually size the hot runners, the manifold properly. There are many different solutions right now in the plastic industry that can be offered in order to maximize or make very fast color changes. So again, be informed on whatever the market can offer and make sure that you can, get a very good hot runners. But, discussing about the mold, definitely starting from where the plastic enters the mold, we need to make sure that in here we don't have mismatches in between the mold and the nozzle. Again, a little mismatch in here may create very long color changes. Also, the manifold is extremely important. Make sure that the manifold is properly sized. And again, it's going to have a good thermal uniformity. We will discuss that a little bit more in the next few slides because it is extremely important. Make also sure that the bushing in the manifold are sized properly and they fit. Basically, there are not dead spots in there. Many molds or many manifolds are made with different solutions. Definitely, we see that a lot where basically there are plugs in the manifold that are inserted there where they create like very, very big dead spots. Definitely, that's a problem. So, again, it's extremely important to make sure that we get a good manifold and a good mold. Valve gate versus no valve gate, definitely that plays an important role. If we have, we will see that later, it's always recommended, if possible, to install a tip insulator. Tip insulator normally they maximize the color changes, so they will allow you to make very, very fast color changes. And again, also the tip area is extremely important, and the nozzle of the hot runner is extremely important. Now, as we were discussing, the melt, the sizing the manifold is one of the critical points of building a good hot runner. We want to size the manifold needs to be sized in a way that the speed inside the manifold is not too high to create too much shearing, so to burn the material, but at the same time not too slow to have too much material sitting inside the manifold. That will actually create a lot of problems during the color changes, but a lot of degradation problems as well. Now, make sure that the manifold has a good thermal stability is extremely important. Again, as you can see from this little picture in here, if the temperature of the melt channel is not uniform, basically we're going to have areas that are very hot and then they go very cold. So you can see that where the cold area is, more color actually tends to stick on the wall of the melt channel. And this is basically the same melt channel where there are different sections, and you can see that the cold area is covered by a black layer of color, while the hot area has a lot less black color in there. The reason why is because obviously the more we increase the temperature, the better the plastic will flow, so the easier it will be to remove the previous color. Same, basically, analysis can be done in this particular melt channel, where basically if we don't have a uniform temperature, again, we will have problem with the color hanging in the melt channel. Also, planning, as we discussed, is extremely important. I know that everybody knows that, and I also know that it is difficult to plan sometimes because we have to go our customer orders, right? So if sometime, even though we mean to plan the production good, but because an order comes in and is a rush, we have to run that job right before it. But whenever possible, definitely, it is very important to plan wisely. Again, as you can see from this slide, if we have like a different color, like going from yellow to blue, we have 250 shots, obviously without using purging compound. And then from blue to green again, we have another 150 shots. And then green to lighter blue, under 50, and then obviously we go darker, we have only 50 shots. So basically, we may have like 600 shots to perform this sequence of colors. Now, we can perform the same sequence of color, but this time by planning, right? And we can go from blue to yellow, and then yellow to green, and then green to a dark blue, and then back, and close the loop. And in this case, we will have only 400 shots. So just by planning wisely, we will have like a 33% reduction in scrap, basically, in resin. Also, definitely, using purging compound is extremely important. Purging compound normally is proven they can drastically reduce the scrap and downtime. For example, in that particular case, the two slides above, in the color changes, the same color changes performed with the UltraPurge will be able to actually give a reduction of 80% in scrap alone, which is definitely a huge saving. Now, normally, when we analyze the purging process, there are two main components, or two main costs that are generated. Normally, the cost, there is the scrap, and there is the cost of downtime. The scrap, everybody knows what it is. It's basically the material that we scrap during the color changes. The downtime is the time that is necessary for us to complete a color change. But many times people don't give the right value to the downtime, because the downtime keeps in consideration definitely the loss of production, the energy used to actually run the machine while purging, because the machine is still working at 100%, but it's not actually making good parts, and also the manpower, because normally when we purge a machine, we also need a person, or even sometimes two people, that they will collect parts from the machine. Scrap, again, is normally the smallest component if we analyze a purging cost. Also because many times the scrap can be either sold, or, depending on the product we were making, can even be regrinded and used back in production. So scrap, normally, it is important, but it is not the biggest cost. Even though most of the companies are normally monitoring the scrap that they produce. And actually, the scrap is normally used as an indicator of the efficiency of a company, right? The lower the scrap that we create, the more efficient we are, which is correct. Now, talking about downtime is normally the largest component in terms of cost, right? And it's lost. It's all money that is 100% lost. If it takes 1 hour for me to complete the color change, it means that in that hour, my machine was not producing good parts. So it means that in that hour, I actually spent the money to run the machine. I lost the money because I did not produce parts, and unfortunately, I cannot recover the time back, like I normally can recover at least part of the cost of scrap. So that's why make fast color change is extremely important. Make sure that whatever we're doing it in a very short time. And that's why the setup of the machine is also extremely important, because we do not have to monitor only the scrap, but we need to make sure that even if you're using purging compound, that we're going to be fast in loading the purging compound, we will be fast in setting up the machine before loading the purging compound, we will be ready with the next production material, because every minute that we lose is actually a lot of money in the end of the year. Now, using UltraPurge has proven an efficiency in reduction of scrap, actually, in between 50 to 80% and 60 to 80% in reduction of downtime. Now, these numbers are very far apart, 50 to 80, 60 to 85, because, again, that depends on many different factors. Again, as we said before, this is a system approach. This is not a miraculous solution. It really depends on the setup of the machine, on the polymer, on the colorant, on the type of hot runner. So sometimes we can achieve very high savings, very close to 80%, sometimes even 90%. But sometimes we cannot because of the design of the machine or the type of current, and we are down to 50%. But definitely consider 50% as a very conservative number. It is always correct. So using UltraPurge can always save at least 50% in reduction of scrap or definitely in downtime. By using UltraPurge also will help you to improve the quality of the parts or the production that you're making. Why? Because by using the UltraPurge, as we will see in the next few slides, we will deeply clean the machine. So we're making sure that the machine will always be very, very clean. So no remnants of other color or polymers will stay inside the machine. They may create problems with the carbon deposits or black specks or even streaking coming from other colors. And definitely also when used for shutdowns, the UltraPurge will eliminate potential problem with carbon deposit with thermosensitive resins. So basically, for material changes, color changes, or shutdowns, by using the UltraPurge, will help to reduce the scrap and the downtime, so basically increase profit and productivity and basically be more competitive in the market. And that's basically what all we want, right? Now, we will discuss a little bit more about the UltraPurge itself to better understand the technology. There are many different kinds of purging compounds in the market, but they can all be divided into main families, because they're what they're called the mechanical purging compound and what they're called the chemical purging compound. Mechanical purging compound normally are purging compound that they have some sort of filler in there. It could be everybody's own technology. It could be from mineral filling, could be acrylic and glass fill. Everybody's own technology. And then there are chemical purging compounds. Chemical purging compound, they have a chemical ingredient in there that will be able to chemically react with the polymer. And we will see later on how it actually works, so we make fast color changes. Now, what's the main difference in between chemical and mechanical purging compound? Normally, with mechanical purging compound, because the way they work, you need to use much more material compared to a chemical purging compound. Obviously, it's easy to understand that with the mechanical purging compound, you will have to keep running purging compound until your machine or system is clean. With the chemical purging compound, because it works on a chemical reaction, you will be able to let it soak inside the machine for a few minutes and then let it work in there and then remove it, and then it will be able to actually clean your system. Definitely, the UltraPurge is designed to clean screw barrel, again, hot runners, because since we don't have any particles inside the UltraPurge, they may clog the hot runners or may get stuck in the manifold, it will be very easy to run the UltraPurge through the system. Actually, UltraPurge, once melted, it really behaves like plastic. Actually, it's even possible to mold parts with the UltraPurge. Now, how does the UltraPurge really work? Basically, there are different ingredients in the UltraPurge. There is an active part that it is the one that actually is designed to chemically react with the polymer that is inside the machine. We have an expanded agent that is designed to actually carry the active part in all the dead spots of the machine. And the dead spots is normally what give us the problems, right? The dead spots is normally where we have the color that hangs inside the machine. Normally, the parts of the machine where we have a good flow resin normally are the ones that are clean, but the dead spots, the one that make long color changes. And what is important to say, the UltraPurge cleans at the same temperature of the resin that you want to clean. So there is no need to drastically change temperature. It's better to say that maybe there is some temperature that needs to be changed only in some specific area of the machine. Now, for example, if we think that this one is a molecule of high-density polyethylene, now I put this in a very simplistic way, so it's very easy to understand. But if we think that the red dot is actually the pigment. Now, the pigment in reality is not as small as in this design, but suppose that it's bonded to the identity polyethylene. This, by using the UltraPurge, we will be able to actually break the molecular chain of the polymer, so that what we will do, we will drastically increase the melt index of the resin. Now, by increasing the melt index of the resin, what will happen is that the resin will be able to flow inside our injection unit or even the hot runner much faster. Faster than we move from a profile like this one, where we have a very high speed in the middle of the melt channel with a very low speed on the side of the melt channel, to something very similar to this, which this one is the ideal flow of the resin inside the melt channel, right? Where basically the speed of the resin will be much more uniform. Now, the UltraPurge, again, can be used, as we discussed, for injection molding machine, all type and size, hot runner system, injection blow molding machine, compression molding machine, and definitely extruders or even blow molding machine. Basically, any machine that uses thermoplastic resin, the UltraPurge will find an application for it. Why to use UltraPurge? This is definitely a big question. The only reason to use UltraPurge is to save money. If UltraPurge will not prove you that it's saving you money, there is no one reason for anybody to use UltraPurge. It is definitely very important. The way our company operates, or the way we approach our customers, is by saving them money. If we don't save them money, there is no one reason for them to switch from whatever solution they have to UltraPurge. It doesn't matter how much is the cost of the purging compound. It doesn't matter how much is the cost of the resin. What matters is the final number. What matters is how much money we'll be able to save every color change. Definitely, the other reason of using purging compound is to improve quality of production, but that is something that comes with it. Or to make fast startups, definitely is always because, you know, if you make fast startups, you will be able to actually save money. And also to solve some side problem, like, for example, slip screw problems. Sometimes are common with, you know, the usage of liquid colorant. So definitely the UltraPurge can help that. And for some specific resin or for some specific additives, definitely the UltraPurge can prevent from steel oxidation or even from the oxidation of the polymer. Inside the UltraPurge, we have an antioxidant ingredient that will actually be ideal when used for shutdowns, because by oxidizing itself will prevent the oxidation of the polymer. Now, this is a very simplistic cost analysis that this one is actually a closure application on a machine running polyethylene. Basically, is a comparison in between running just resin versus running the UltraPurge. As you can see in here, basically with just resin, they use about 100 pounds of resin, and it cost about $65, and it took about 3 hours to complete the color change. $150 per hour. They had a total downtime of around $50. Now, if we sum the cost of the resin plus downtime, we have an overall cost of $515. Now, by using the UltraPurge, they use only 6 pounds of UltraPurge. Again, with the UltraPurge, we need to use only 1 barrel full, so very, very small amount. Normally, it's half or the third part compared to a mechanical purging compound. Now, the cost of the polyethylene, it was always 65 cents. Now, the cost of the UltraPurge in here, and we purposely put the cost at $6 per pound. Obviously, the UltraPurge does not cost $6 per pound, but we purposely put at that price in order for you to understand that the cost of the purging compound, it is not that important. It's not that relevant, because the amount of purging compound that you use is actually very little compared to the overall resin that you're going through. So you have a cost of material of $45. Now, we completed the color change in only half an hour at $150 per hour, so $75 total. So basically, the overall cost with the UltraPurge was $120, $121. So we saved in this particular color change $394. Now, this is very important to understand that if this bottom line, this number, is not in a saving section, again, there is no reason whatsoever to use the UltraPurge to switch to our material. Now, what are the benefits of the UltraPurge? Definitely, as we discussed, it's very efficient in the cleaning process. Very small quantity are required in order to clean the machine. It is totally moldable, extremely important, especially for the hot runner application. We're able to mold parts with the purging compound. Cost effective, as we said, very small quantity are required, easy to be removed from the machine. And we're proud to say that we are actually food contact certified according to the FDA and the European regulation. It's extremely important for all kinds of food food application, even sometimes medical application. So easy to use and definitely odorless, so no odors or fumes are related with the usage of the UltraPurge. Now, this is our product line. It's very wide. Obviously, we have great design for every for specific application, as well as grade that we recommend for general purpose. So basically, based on your needs, we normally try to provide the perfect solution in order for you to make sure that you're not carrying 10 different grades of purging compound that will make actually your life and color changes easier. Now, in here we will, there are the purging procedures that I don't really want to analyze because we will not have a lot of time. But what is important to show, and that's something that I wanted to point out, is that the usage of UltraPurge is different from other mechanical purging compounds. This is what is extremely important. That's why we normally ask our customers to strictly follow the procedures. Procedures in using purging compound are extremely important, not only for the UltraPurge. Every purging compound producer has its own procedure, so it definitely is important to follow the right procedures. Our procedures are actually very extremely easy, but little different. One of what makes us different is that we normally ask to keep the barrel of the machine full of the previous color that we want to remove, and then load the purging compound right on top. Then there are other parameters that need to be changed, but they're very minor. And normally, our technical staff can go through these steps with you. Normally, a soak time is also required. Soak time is required normally only for raising with a lower temperature. If we are talking about raising with higher temperature, no soak time is required. But for like polyethylene, polypropylene, or PVC, maybe 3 to 5 minutes soak time may be required in order to complete the reaction. Now, in here, pictures that you can see of the purging compound. As you can see, the purging compound totally looks like plastic, and this one is a color change from black to white. So you see how the purging compound actually removed the black color very easily. Now, when it comes to hot runners, we actually have two different solutions. We can clean the hot runners with the mold open or with the mold closed, depending on what basically we want to achieve. With the mold closed, basically we're molding parts. With the mold open, basically we shoot the purging compound through the mold with the mold open. This procedure basically will be, we will recommend to do one or the other one based on the type of product and the size of machine and the type of resin that you're actually running in your plant. Now, in here, for example, a picture of a sequence of caps. As you see in here, these caps are 100% molded with the purging compound, which is extremely important. Purging compound is at 100% concentration, so there is no need to dilute the purging compound whatsoever. This is what we discussed before. The bubble or the tip insulator is extremely important. As you see, there are many different colors that may hang in the tip insulator. For this reason, we normally recommend to increase the temperature of the tip insulator, or to actually install or get in contact with your hot runners manufacturer and install a tip insulator. As you can see from this picture, this is a very large bubble. When we put a tip insulator, we definitely reduce the bubble area, and that will definitely help us reduce the overall color change. It is proven that by using a tip insulator, we can reduce the overall color change by 75%. It is a huge number just by using a tip insulator. Also, this is a typical problem of color hanging on the walls of the hot runner. So definitely, with the way the UltraPurge works, by increasing the melt index of the resin, we'll actually be able to make that color flow out of the hot runners much easier, so maximizing basically the color change. UltraPurge, again, can be used also to remove black specks, and this is actually a very difficult application because those are syringes. So actually, this is purging compound molded into the shape of a syringe. So definitely, this is a very thin part, but even if it's thin, the purging compound was able to be molded and actually remove carbon deposits. We also have a specific grade that we designed for stack mold application. That is 100% moldable, even with the mold that normally run resin with a melt flow of 40, 50, 60, even 80. And this is a new solution that we have developed with one of our customers. And definitely it is very efficient in order to clean the hot runners. The only solution with stack mold is actually to mold parts in order to clean the hot runners. Always watch the mismatch, as we discussed before, in between the nozzle and the mold, basically, in order to make sure that there are no dead spots in there. Also, UltraPurge can be used for extruders. The procedures are more or less the same as injection molding. Obviously, always work with the barrel fold. That's the main difference in between us and other mechanical purging compounds. Again, all we want to do is to make sure that the UltraPurge will stay in contact with all the walls of the machine. Some picture of the purging compound coming out from a compression molding machine, and actually same here. Now, our company is located basically in the two main continents, so Europe and Americas. We have office in Italy, United States, and Mexico, and distributors throughout the world, basically. So it's very easy to source the UltraPurge throughout our distributors, definitely. So to conclude, basically, we need to make sure that we use good pigments. So we consult with our color manufacturer, making sure that, yes, we're using the pigment that our customer wants, but also, according to our need, will be easy to be removed from the machine. Also, we have to make sure that we will have, at the time we purchase hot runners, we will purchase the right hot runners for our application with the properly sized melt channel. The manifold that will have a very uniform temperature, and also that we will not have a lot of dead spots in there. Definitely, again, improving the mixing of the color and the resin inside the machine is definitely extremely important as well, in order to make sure that we will not have the gel problem that we discussed before. Again, to conclude, to make fast color changes, know your resin, know your colorant, get right equipment, the right equipment for your application, use a good mixing to disperse the color. Again, purging compound will definitely help, and apply good purging compound procedures. This is the key to actually become more efficient in color changes, and to make sure that you will start to actually save money in between colors. Now, again, we will have, we had only a very small amount of time in order to complete this presentation, so there are many more information that we can share with you and actually personalize based on your needs. And I wanted to leave a little bit of time actually for questions and answers. So at this point, I don't know if, let me see what some answers that are coming actually from some attendees.
Yeah, and Graziano, if folks from in the audience would like to chat in your question, just make sure you type that into your question box and submit it, and then we'll review those and answer them as best we can. Sometimes questions aren't very easily answered in a format like this because they require a little bit more back and forth. So in those cases, we may table some of those questions and have Graziano and his technical team answer those with you later. But they will be following up with those.
I have a question here, for example, from one of the attendees say that they have polyolefin, and they would like to know what the grade is best to be used for this kind of application. Again, we have a grade specifically designed for this application. It's actually called UltraPurge-P-O, means polyolefin. And it's actually one of the most popular grades that we have, and it's a 100% moldable purging compound, so it can be molded into parts. So if they also run hot runner system, so definitely this is one solution. But again, our technical staff can definitely help with that. Another question that I see in here is somebody asking, oh, how long, what happens if we leave the purging compound longer inside the machine? Nothing will happen. The purging compound, we normally recommend a 3-minute soak time, just in order to be efficient in terms of time. But the purging compound can be left inside the machine even for an hour, half an hour, but it makes no sense because we will actually waste time. And since we want to become efficient, we want to make sure that we don't waste, basically, we don't waste time. Another good question is, what can I do with the scrap produced by the UltraPurge? UltraPurge is actually 100% recyclable. We have customers that they are selling the UltraPurge along with their own production resin, such as polyolefin or whatever. We actually have customers that are reusing the UltraPurge to make parts. Once the UltraPurge reacted once inside the machine, becomes 100% inert. So that it can actually be used, depending on the type of part, the quality of part that you're making, to actually make good parts. So you can recover the cost or part of the cost of the UltraPurge, definitely. Another question that I've seen here is, does the color and pigment affect the mechanical property of the plastic? Definitely yes. We know that. It is proven. That's why it is important to select proper color and consult with the color manufacturer and also the resin manufacturer, and making sure that the property of mechanical property of the polymer will not be changed. Again, there are many different solutions when it comes to color. The same color that can look the same to us or our eyes, actually, chemically speaking, may be very, very different compared to different within each other. I have another question here. Will the purging compound do any cleaning of a standard mold? Example, events. Okay, the purging compound, the UltraPurge, will be able to clean the hot runner system in the machine, or will be able to clean anywhere inside the machine where there is melted and hot plastic. Definitely, the purging compound will not be able to clean the cavities of the mold. This is very important to understand. The purging compound, as soon as we leave the cavity of the mold, will cool down very fast. So it will not have the opportunity to clean the cavity of the mold or even the vents or anything like that. So no, the answer to this question is you cannot use the UltraPurge to clean the vents, or sorry, to clean basically the mold. How do I clean a stack tool? Again, cleaning stack tools is very tricky. Unfortunately, there are not many solutions out there. In order to clean a sector, you need to make sure that you will be able to 100% mold the purging compound. Again, we have developed this solution with one of our customers. It's a completely new grade that will be able to actually not alter the melt index of the resin that you're running, and it is 100% moldable. So you will be able to make parts where you're actually cleaning the hot runners. Will the UltraPurge work for 1-inch extruder running fluoropolymers? I don't see why not. Definitely we have a grade called HT grade. Is a grade that will go, we work up to 716 degrees Fahrenheit, about 400 degrees Celsius. And it is designed for all kinds of high temperature application, can be used also for extruders. And so definitely, yes, the HT grade will work also for this application. I see that there are a lot of actually questions coming, and I'm very happy. I will try to answer to most of them if possible. What is the best way to get rid of black specks? This is a $1 million question. Black specks may come from many different sources. It may be the